right. Today we're going to finish up our properties of exponents. Let's recap the rules that we know so far. We know that when we are multiplying, we need to add the exponents. When we're dividing, we subtract the exponent. If you have a power raised to a power, you will multiply the exponent and make sure you distribute. And then one that kind of snuck in right at the end there. Anything to the 0 power is 1. So this whole term here was raised to the 0 power. It's all going to cancel out and make the number 1. So let's get into our last two rules, which are the negative exponent rule and exponent to a radical rule. So the negative exponent rule, I like to think of this as flipping, quote unquote. So let me go through a few before we write that little note down. But the negative exponent rule, you cannot have a negative exponent to be simplified. So in simplified form, there are no negative exponents and there are no fractional exponents. Now, looking at this problem, it's x to the negative second power. Let me put in my understood denominator. Anytime you see something, the understood denominator is 1. So I can't have a negative exponent. So we're going to flip it to the bottom of the opposite of where it started from. So it started in the numerator. So it's going to go to the bottom and it's going to become positive. So this is our answer. So if it's in the top, flip it to the bottom. If it's in the bottom, flip it to the top. This one over here, we're going to flip it to the opposite. So I have a negative that's in the bottom. We're going to flip it to the top. So this is going to be a to the third. And you don't have to put it over 1. You could put over 1, but we generally don't put a denominator of 1. So this is our final answer. So this is why I like to think of this rule as flip it. So up here, let me write right here. I'm going to say flip it. So you flip it to the opposite of where we are. So for the negative exponent rule, flip it to the opposite of where it started at. If it started in the top, flip it to the bottom. If it started in the bottom, flip it to the top. So let's go through and do some more. This example here, a to the third, b to the negative second power, c to the negative fourth power, and d. You only flip the part of the problem that has the negative exponent. So b and c are the only parts that need to be flipped. So a to the third is going to stay on top, and d is going to stay on top, as in the numerator. B is going to go to the bottom, and c is going to go to the bottom. And once you flip it, they become positive. So this is b squared c to the fourth. And that's our final answer. Can't do anything else with it. Next example, 4a to the negative third, b to the negative third, divided by c to the negative first power. I got lots of different things I need to flip in this problem. The a and the b need to go to the bottom, and the c needs to go to the top. And once we flip them, it becomes positive. So my final answer, the 4 is the only thing that stays where it is. So the a and b now need to move from the numerator to the denominator. So that'll be a to the third, b to the third. And c to the negative first power needs to move from the denominator to the numerator. So that'll be c to the first power. And you don't need to put that 1 there, just putting it there so you know that it was negative and then we flipped it. Okay. Couple more that we'll do. We have b to the fourth divided by b to the fifth power. Now I got some options here. I'm actually going to use one of our rules from yesterday. This is 4 and this is 5. So we know that when we are dividing, we are supposed to subtract the exponents. So 4 minus 5 gives me b to the negative first power. Now, this automatically is in the numerator. So when you flip it, not flip it, but when you subtract, automatically go ahead and put your answer in the numerator. So I need to flip this to the opposite. So my final answer is going to be 1 over b to the first power. So I use 2 rules, which is fine. So for a lot of these problems, you might have to use 2 rules or 3 rules in combination. There's nothing wrong with that. So this is 4 minus 5. That gave me b to the negative first power. And then that was in the numerator, so I flipped it to the denominator. And last one, 4r to the 5th, z to the negative 10th, divided by 10r to the 9th power. Again, this is one of the ones I could do multiple rules, lots of different rules for this one. I'm going to go ahead and simplify 4 divided by 10. So go ahead and simplify that. That's going to be 2/5. So 4 divided by 10, reduce your fraction. That reduces to 2/5. Now we're going to subtract. So this is 5 minus 9. Go ahead and put that in the top. We know we're not finished. I'm just putting it in the top for this time being because I did 5 minus 9. So go ahead and put it on the top. Now I got a z. The z needs to go ahead and move to the bottom. So it's in the numerator. I'm going to move it to the denominator. And my final answer, we can't have this negative exponent here, so we know that it's going to be moved to the bottom. So my final answer is going to be 2 over 5 r to the 4th z to the 10th. So final answer, 2 stays on top. This -4 needs to be moved to the bottom, and we had already moved the z from the top to the bottom. So that is our final answer, 2 divided by 5r to the 4th z to the 10th power. And our last rule that we're going to talk about, I'm going to show you how to move from exponent to a radical, which is the math terminology for a square root. So this symbol down here where we see the square root of m, that symbol is called radical. So I'm sure you've seen it before. You probably call it the square root, but it's called radical. So I'm going to show you how to go from exponent form to radical form, then from radical form to exponent form. So that's what vice versa means. So we'll go one direction, then we'll flip it, and we'll bring it on back, vice versa. All right, so I have an exponent. It's 27 to the 2/3 power. Now this is a number. Since it is a number, of course, so we can type it in a calculator or something like that and actually get what that number is. But I want to show you how to take this from being an exponent form, specifically a fractional exponent, how we can flip it and make it be a radical. So if I were to flip this problem, okay, if I rewrite it using a square root, using the radical, it would be rewritten like this. Your numerator of your fractional exponent goes on the inside of the square root, and your denominator becomes the number on the outside of your square root. So that number is called an index. It's a little tiny number up here in the corner. It's called an index. You probably can see it a little better down here for that example where my pen at. My index is 3. So it's a little tiny number on the outside of your square root. Here's another example down here. A little tiny number on the outside of your square root. So this is how you rewrite it from looking in a fractional exponent to looking in radical form. Now, what this means is I don't want to know the full power of 27. I just want to know 2/3 of it. Now, I already know that the cube root of 27 is 3 because 3 times 3 times 3 is 27. But I don't want to know the whole part of that. I only want to know 2/3 of that. So this actually simplifies to the number 9 because 3 times 3 is 9. Now, if all that was a whole lot, you're like, okay, Ms. Carver, I don't really know what that means. This is a number, so you by all means can type that in and it will give you the number 9. Next one, we have y to the 1/5 power. We want to convert that and make it look in the other form, make it look like a square root, a radical. So if I rewrite it, it looks like this. Okay, same thing I did with the first one. Your numerator becomes the number on the inside, and the denominator becomes your index that's on the outside. So denominator goes on the outside, and your numerator goes on the inside. You technically don't need to put this one there, but as you know, because I know I've said it a lot, the one there is just there to help you out. So that is my answer. Okay. Next one, I have r to the -3/5 power. So the first thing I'm going to do for this problem is first, it's a negative exponent. So I'm going to flip it using our negative exponent rule. So this is going to look like 1 over r to the 3/5 power. So the first thing I did, we can't have a negative exponent. That's one of our rules, so I flipped it. It was in a numerator. I flipped it to the denominator. Now, this is not simplified. We only want whole exponents, whole W-H-O-L-E. We only want whole exponents in my bottom. So I need to make it be a whole number. So if this is 3/5, if I multiply by 2/5, when I multiply, it will then be a whole number. And let me show you how that is. 1 times r to the 2/5 is r to the 2/5. You add the exponents here. 3/5 plus 2/5 is 5/5, which is a whole. So that is a whole number. Finally, I can convert this to a radical. So in radical form, it's going to be 5 over r. So this process formally is called rationalizing the denominator. So we cannot have a fractional exponent in the denominator to be simplified, quote unquote. So how do I make it be? You multiply it by something that when you add it together, it's going to make it be a whole number. WHOLE, a whole number. All right, next, 3, the cube root of 5 is how you would read this out loud. So the cube root of 5. Let's just convert it to a fractional exponent. So we're just getting comfortable going from one form to the next. So in exponent form, it's 5 to the 1/3 power. Okay, this is asking us to do the square root of 10 to the 3rd power. So we're doing the square root of 10 times the square root of 10 times the square root of 10. So let me write out this. So this is what they're asking us to do. So the square root of 10 times the square root of 10 is the square root of 100. The square root of 100 is the number 10. Again, the square root of 10 times the square root of 10 is the square root of 100. The square root of 100 is the number 10. And I have the square root of 10 that I need to bring down. And I can't do anything else with it. So my answer is 10 times the square root of 10. Next, we're just practicing converting from one form to the next. So if I rewrite this as a fractional exponent, it's x to the 5/4 power. All right, I'm going to rewrite this. We can't have a square root in the bottom, so I'm going to multiply both the top and the bottom by the square root of m. This problem is like the one right above it. This is m to the 1/2 power. You cannot have a fractional exponent in the denominator. So this is m to the 1/2 power. Let me write that out in a different color. So this is m to the 1/2 power. I'm multiplying it by another m to the 1/2 power so that when I add these together, I get a whole number. Whole as in WHOLE, a whole number. So on top, I have the square root of m. And on bottom, I'm just left with m. So that's our final answer. All right, 2 more we'll take a look at, just converting from one form to the next. This is in fractional exponent form, so I need to rewrite it in radical form. So in radical form, it's going to be the 5th root of 32 to the 4th power. Okay, that is a number. I can put in 32 to the 4/5 power into a calculator. It will give us 16. And last but not least, I just want to convert this. It's in radical form. I want to convert it to exponent form. It'd be x to the 2/3 power. So now we know all of our properties of exponents. We know how to switch it from an exponent to a radical, from a radical to an exponent. Negative exponents, we flip it. Our other rule, we distribute and then multiply. Anything to the 0 power is 1. And then we have all of our rules from yesterday as well. So we now can complete our Canvas assignment.